All right, so now I'm going to start with you with this first one, okay? So you told me that Li has a charge of what? All right, now, if you come over here and look at this, I want to spend just a little bit of time as we talk through this to explain something. So what do you notice about this entire group that I just circled in green? They're all 1 pluses. Now, my question to you is, what group is that? Group 1. What's the name of those things? The alkali metals. Now, let me ask you something. How could you know that all of group 1 is +1? What do we know about group 1's electrons? Hang on. There's a lot going on. Hang on. How many valence electrons do they have? 1. And what do they want to do with that 1? They want to get rid of it. So that's why they're all +1. Okay? So we've got that answered. So we know that lithium is going to be +1. Okay? So now let's flip over to the other one. The other one is F. Now, the interesting thing about F, if you notice, again, that entire column is all what charge? -1. Now, first of all, what group number is that? 17. Blaze, what is the name of that group? Halogens, okay? Brennan, why are they -1? They want to gain 1. Very good. So when you take something in that's negative, it turns you negative. So we know that fluorine is going to be -1. Now, yesterday I taught you 2 methods to create the formula. How many of you, again, this is a teaching moment. I need to hear your feedback. How many of you prefer the math method where you actually calculate it? Set it equal to 0 and calculate it. That's perfectly fine. So if you did that method, I've got 1 positive and 1 negative. Remember, we set it equal to 0. So do I need to add either of them to make it different? No, so I have one of each, right? So I've got Li and I've got F. So that should be your final answer for that one. Now, the other method I taught was the crisscross method. How many of you prefer the crisscross method? Again, either one is fine. It does not matter. So I put a 1 there and a 1 there, and that's going to leave me with my answer. Okay. Now, remember how we first started doing orbital notation and you all laughed at me when I started doing half arrows? And I said by the end of it, most of you will convert to it because it's just much more efficient. My hypothesis is most of you by the end of this will convert to the crisscross because it's so much quicker. Okay, and we'll kind of talk about that one. All right, so the next one, we've got Ca and we've got O. So let's go back over here and let's look at this. So this column, what do you notice about all of the charges that are in purple box? They're all 2+. Now, what group is that? Group 2. Why are all of group 2 2+? They lose 2. Very good. So that entire group. So when I ask you about these different metals, you never have to look them up. You never have to figure out what they are because all of group 1 will always be 1. All of group 2 will always be 2. So you never have to really think about what the difference is. Now, so we come back over here. We now know that calcium is a 2+. So let's go back and let's look at oxygen. Now, I understand that there's only 2 in this column, but you've got to remember that the stair-step line runs through here, and these 2 are going to be really weird, and we're going to rarely see those, and we'll kind of talk about them at a little bit later date. But again, if you notice that these 2 are both 2 negative, what group number is that? Group 16. So how many valence electrons do they have? 6. Well, how many more do they need to gain? 2. That's why they're both 2 negative. Okay. So we come back over here and we put for calcium. If we say calcium is 2 negative. Now, if we do this the math way, again, some of you prefer that. If I set this thing equal to 0, I've got 2 positives and 2 negatives. So do I need to add anything to this? No. So that then gives me CaO. I only have 1 of each. Now, if we do the crisscross method, there is one additional step, and let me show that to you. So if I crisscross a 2 there and crisscross a 2 there, I would get Ca2O2. But just like I asked you yesterday in math class, would that be an acceptable answer? Why not? It's not simplified. So then if you reduced it, it would be CaO. So no matter which method you choose, it's going to give you the same result. The crisscross method, sometimes there are going to be some stipulations where you have to pay attention to the very end. Okay? All right, the last one. What is the charge on aluminum? All right, so it's going to be 3 positive, and sulfur was, why did I write another S? All right, so it's going to be 2 negative. Now, this one you actually had to do a little bit of calculating. And remember, this is the one where I told you this was that 2, 3, 6 rule. So because 2, 3, and 6 are the lowest common multiple of each other. So if you have a 3, what did you give it? 2. And if you have a 2, what did you give it? A 3. So when you wrote the formula, you should have had 2 aluminums and 3 S's. Does that make sense? Yes, sir. Okay. So when I multiply 2 times 3, what is the answer to that? 6. When I do 3 times 2, what is that? 6. So I've got 6 positives plus 6 negatives. What would that equal? 0. Well, everything has to be equal to 0. So that's why, and all I did was bring them down. If you do the crisscross method, the 3 goes there, the 2 goes there, which is exactly what we have. Okay. Yes. What is what? That tells me that I've got 2 aluminums. This right here. This, all right. I mean, because that was all kind of fuzzed up. If I want to set this thing equal to 0, right now I've got 3 positives and I've got 2 negatives. Okay. Well, I've got to make them equal to. I've got to make this whole thing equal to 0. Remember, but this is our 2, 3, 6 rule, right? So if I've got a 3, put a 2 in front. That's 6. Correct. Okay. If I put a 3 right here, that is 6. You're trying to make it cancel each other out. And then what I do is I just say, well, there's 2 aluminums here, so I'm just going to put that there. And I've got 3 S's there, so I'm just going to put a 3 behind that. Does that make sense? Okay. All right. So now let's kind of move on to where we stopped yesterday. And what we're going to do is we're going to learn that we're actually going to kind of, what's the word? It's going to make things make more sense. All right. So question number 4. Circle the symbol for the metal in each of the compounds in Model 2. So when you did that, what element did you circle in every single one of them? Very good. If you went back and you looked, all of these first symbols are all metals. So before I even ask the next question, then what is your hypothesis about when the metal is written? It's always written first. So look at the next question. Which element comes first in the name and the formula of the compounds? The metal or the non-metal? The metal. Now here's what I need you to do me a favor. Most of you probably have the word metal written, but I also want you to write this, please. Because you're going to hear me use that phrase more often. Now, what is a cation? Something that is positive. And if you go back up here, and I promise I'll come right back to this. If we go all the way back to the top, and I draw this stair-step line in again, my first question to you is, on what side of that red line are all of the metals? They're all over here. And what are all of the charges on every single atom in that entire block? They're all positive. And if you notice right here, and I kind of highlighted over it, what is that word? Cation. You're going to hear me refer to it more as what is the cation versus what is the metal. Because I want you to make sure that you kind of make a connection to those two things. Okay? All right, number 6. Use the table of ions in Model 1 to answer the following questions. In the compound zinc phosphide, what is the charge on the zinc ion? Now, you're probably going to have to go all the way back up to the table. So if you do that, what is the charge on zinc? 2+. Okay, look, right, it is right here. If you don't know where it is, put your eyeballs on it right there. Okay, that is zinc. So go back down to that one and write zinc 2+. Let me need this for just a second. Okay, so I've got Zn 2+. Now, there's something weird about this. Hey, will you handle them for me? Okay. Just see him. He'll take care of it. Now, is it coins? Here, hand me the coins. Yeah, 11 tomorrow. Okay. Now, I need your help. Yes. Only 3 of them. Group 1's always 1. Group 2's always 2. The only 3, and let me say this out loud so you guys are listening. I know half of you aren't. So here's the deal. Bailey asked, she said, do I need to memorize all these charges? So there's only 3 that I asked you to memorize. Group 1's always 1, so you don't have to memorize that. Group 2's always what? 2. These 3 right here are the only 3 I'm asking you to memorize. And I know what you're saying. One of those is a blank. What do you mean? What did you add right there in that blank? All right, so it should be CD2 plus. Those are the only 3 in the entire periodic table that I'm asking you to memorize. Okay? Now, the other ones, we will get to utilizing them more often, but those are the only ones that you have to have memorized. Because, and that's a good question. Now, if I box this, what did I just box in? I boxed in all the transition metals. What do we know about transition metals and their charges? They usually have more than 1. Okay, but here's the problem. If it's a transition metal, and I told you this yesterday, whenever you see the name of a transition metal, what has to be a part of the name? The Roman numeral, remember? Well, the problem is, those 3 are transition metals. But when you see the names, prime example, do you agree that zinc is in the transition metal box? But when you scroll down here and you look at it, right here, what do you notice is missing from right there? There's no Roman numeral. So if you don't know that zinc is a 2 plus, you're going to mess up the formulas. And that's why you have to memorize it. So if it were silver phosphide, you don't know what silver's charge is unless you have it memorized. Same way with cadmium. So that's why I want you to memorize those 3, because they're technically transition metals, but they only have 1 possible charge, so they don't include the Roman numeral. You with me? Does that help answer the question? Yes, sir. The only 3 that you are required to know. So, Massimo, if that's something you really want to know, I will. Okay. All right, so there's 3 things. What was the 3rd one? Where's Ryan Dismukes? There's the 3rd one. I'm thinking, and I'm waiting on someone to answer the blank.
Wait, I forgot the question.
So the question is, let's go back and look at it. The question is, number 10, explain why, listen, explain why you don't need to specify the number of ions in the compound when you're naming ionic substances, which means you don't need prefixes and you don't have to specify a specific value. Okay, so there was one more in first period that I could not remember. The charges are always known. The sum of the charges must equal 0, and I can't remember. Yes, sir. That is true, but it's not the one that I'm looking for. That is a true statement, but there was something else that I said in first period that I cannot remember what it was. No, I did not. I'll ask first period tomorrow. And I told them, I said, I'm going to forget what this is, because it was one of those that was like a light bulb moment that came to me, and I cannot remember what it was. It is a shame. All right, so number 11. Model 2 is labeled metals that form, and I want you to circle or highlight that word right there. 1 ion. Circle or highlight that little phrase, one ion. What other metals that also form only one ion could it be included in the Model 2 list? Model 1 may help, and that's talking about the periodic table. So you may have a bunch of answers there, but here's something that if you don't have anything, here's what I would put. Group 1, Group 2, aluminum, and then here's one of those memory things that I've asked you to memorize. Who are the 3 transition metals that only have one charge? Now, here's the deal. I know that some of them are already in that list, and that's okay. But these are the ones for this class that you have to do, or you have to know. All of Group 1, all of Group 2, aluminum, cadmium, silver, and zinc. Those are the ones that will always just have one charge that we'll work with most often. If for some reason I give you a worksheet and there's one that just kind of looks odd, or we've never talked about it, or we've never been done, just ask. I don't mind answering those questions. Okay, so, but those are the ones that we'll run into most often. All right, number 12. Describe how the names of nonmetals in Model 2 are changed when they're in their anion form. So here's the first thing I want you to add right here. Nonmetals, are they written first or are they written second? Very good. So write this. They are written. Is it written or wrote? Written second. No. What'd you say? You dang right it is. Proud of it. I'm over here teaching y'all, so that must say something. Okay. So written second. So how are they all? Describe how the names are changed. How are they changed? Very good. They end in "ide." I-D-E. Now, there's something interesting about this. This seems to be a common trend we possibly saw 2 days ago, right? Was this just like covalent? Yes. So any compound you ever name, with the exception of what things? We can actually add it right here. What things do not end in IDE? All of them. Very good, except polyatomics. They are everywhere. They're everywhere. No, not all polyatomics don't end in ion. Hydroxide is one. Peroxide is one. Same exact rules apply to polyatomics. Now you want to know. Now you know why you have to know the charges on the polyatomics to do your crisscrossing. Because if you don't know the charges, you don't know what to crisscross. So I've been literally, like, I would have handed you that entire sheet on Monday and said memorize all of this by the end of the week. So at least you have now been introduced to it. And that's why I've told you we'll get to it. All right, so number 13. Let's see if we can name all of these. So my first question is, and I've been telling you guys this for 3 days now, the number one most missed part about this is identifying what type of compound that is. Because I have a feeling once you know it's either ionic or covalent, you're pretty good on the naming systems. But being able to identify, oh, that's ionic or oh, that's covalent is the most number one challenge thing. And I can't stress to you how important it is that we need to just make sure we practice it enough. So the best way to do it is literally split the atoms. Okay? So if we look at lithium, what type of element is lithium? It's a metal. Now, if you don't know that, how could you know that? Look at the periodic table. What side of... Hang on. She said that she didn't talk to me. So, I don't know why. So lithium, what side of that yellow line or what side of that orange line is it on? It's on the left, and all metals are on the left side. So we've got a metal. Now, we know what oxygen is. We know that oxygen is a what? It's a nonmetal. Well, what type of bond is a metal and a nonmetal? Try that again. Ionic. Same thing. If we take these two and we split them, we've got magnesium. Magnesium is on what side of that line? The left. So we know it's a metal. We know fluorine is a nonmetal. So if we did that with all of these, so if you are not comfortable with just looking at it and determining, do exactly what I'm doing and then label it from that point. So now since we know all of these are ionic, My question to you is, what will you not see in any of these names? No prefixes. Okay? Now, the second thing we need to do is just pretty much name what we see. So, will any of, first of all, so my next question is, could there potentially, because it's ionic, be Roman numerals? Potentially. But what's the case for Roman numerals? Transition. So if we look at lithium, magnesium, aluminum, or potassium, are any of those transitions? No, they're not. So there will be no Roman numerals anywhere in this entire problem. So what is Li? Lithium. Okay? And then we know that oxygen turns into oxide. Very good. So that should have been pretty simple. Okay? MgF2. So we've got Mg, which is just magnesium. Now, you tell me, why is it not difluoride? It's ionic. Very good. I'm telling you now that someone in this room, when we do all this in terms of testing, they will put magnesium difluoride because they're not paying attention to what's going on. Okay, so the whole thing that I just talked about just a minute ago, the number one way to determine is you've got to know if this is an ionic compound or if it's a covalent compound. If it's ionic, what will you not use? You will not use prefixes. And we've already determined, since this is a metal and a non-metal, what type of bond is it? It's ionic. So your question was, how do you know that there is two F's then? All right. Exactly. So we answered that question just a minute ago when we did this. The charges are always null, and the sum of the charges must be 0. And so when we do, what's the compound again? MgF2. So when we do our charges, magnesium is in what group? Do you know? It's in group 2, so it's a 2 plus, right? Fluorine is in group 17, so what's its charge? -1. I'm doing the short method. I'm going to crisscross. So I've got MgF2. There's no other possible combination it could be. That's it. That is the only magnesium fluoride on the face of this planet. You with me? However, if I do this, that's pretty similar, isn't it? But my question to you is, are those two the same things? No. So my next question is this a covalent compound or is it an ionic compound? Either one of them. How do you know they're both covalents? That hydrogen's a non, oxygen's a non, so they're covalent. So how would you name that thing? With prefixes. What is the prefix for 2? Di, so this is dihydrogen. When does the second one have a prefix? Always. So this is dihydrogen monoxide. What about this one? Now this is a trick question. So I don't want to ask that question. We'll talk about that one later. All right. This one. So we've got aluminum. And what would the ending be? Sulfide. Aluminum sulfide. And then finally, Blaze, what is this one? I've done it 3 times, and I still have people that tell me why. Okay, so what do we not have when it's ionic? Thank you, sir. Okay, so does potassium nitride. All right, we're doing 14 and 15, and we're stopping because that's the last part of this section. All right, so number 14, provide the chemical formula for each of the following compounds. Now I'm going to come to the other page to be able to do it, so I have some more space. So it said barium chloride, correct? All right, what's the chemical symbol for barium? Ba. Hey Zeus, what group is barium in? It's group 2. So what's its charge? 2 plus. All right, Jalen, what group is chlorine in? 17. So what's its charge? Negative. Again, my natural instinct is to go right into the crisscross method. I don't want to do any math. The less numbers I have to calculate, the better. So I'm going to crisscross here, and so what should my final formula be? BaCl2. If hypothetically, there was a 4 anywhere in there, what would you do? Reduce. Very good. All right, and the last one, what's the name? Magnesium oxide. So magnesium. Robin, what group is magnesium in? So what's its charge? Emma, what group is oxygen in? So what's its charge? 2 negative. Now, you can do the crisscross, or you can do the math on this one. It's very simple. What happens to the 2 positive, 2 negative? They cancel each other out, so they disappear. So you're left with MgO, and that is magnesium oxide. Okay, hang on. Let me double check to see what the last question is. Consider the 2 chemical formulas you wrote in question 3. That we did that yesterday. With the name okay, this is actually will get us into tomorrow, so we'll talk about this one tomorrow.